Is Schrodinger's cat really alive and dead? In quantum superposition, a cat can be both alive and dead. Until you open the box and collapse the wave function, imagine a world where something can be both simultaneously here and not here, existing in a hazy, uncertain state. And that's precisely the bizarre concept that lies at the heart of one of the most famous thought experiments in all of physics. It's a thought experiment devised by the brilliant physicist Erwin Schrodinger to highlight what he perceived as the unsettling implications of quantum mechanics when applied to everyday objects. Many of us instinctively think about things surely like a cat. For instance, phi as either definitively alive or definitively dead, having a clear and unambiguous state. However, quantum mechanics, the science governing the behavior of matter at its most fundamental level, suggests that things can exist in multiple states simultaneously until we actually observe or measure them. Think about flipping a coin before it lands, it's spinning in the air, possessing the potential to be either heads or tails, and it's not one or the other until it settles. Schrodinger's cat takes this idea to an extreme, presenting a scenario that immediately challenges our common sense understanding of reality. He imagined a sealed box containing a cat, a vial of poisonous gas, a hammer, and a radioactive atom by an atom that has a 50% chance of decaying within an hour. If the atom decays, the hammer breaks the vial, releasing the poison and killing the cat, obviously. But if the atom doesn't decay, the cat remains unharmed, safe and sound, tucked away inside the box. Now, here is the truly mind-bending part. According to quantum mechanics, until we open the box and observe the system, the radioactive atom exists in a state of quantum superposition, meaning it's simultaneously decayed and not decayed. This isn't simply about our lack of knowledge of the atom state, it's about the atom itself existing in both possibilities at once, like a blurred photograph of both images. Because the atom is in this uncertain state, the cat, inextricably linked to the atom through the setup, is also in a state of superposition, meaning it's simultaneously alive and dead. It's not that the cat is secretly half alive and half dead. Instead, the entire system, the cat, the atom, the vial, the hammer, exists in a probabilistic blend of both outcomes. To truly grasp this, consider a wave on the ocean. The wave isn't a single defined crest, it is a complex pattern of disturbance that can be described by a wave function, representing the probability of finding the water at a specific location and height at any given time. Schrodinger used this analogy to illustrate how the radioactive atom and consequently the cat exist as a wave function, a combination of possibilities rather than a definite state. The act of opening the box and observing the system, what physicists call wave function collapse, forces the system to choose a definite state. When we open the box, we force the wave function to resolve, and the cat is then observed to be either alive or dead, but not both. This collapse isn't about our observation changing reality, it's about the inherent uncertainty of the quantum world revealing itself through measurement. Think about a truly random number generator. Before you press the button, the result is fundamentally undefined. It exists as a probability distribution of all possible numbers. Similarly, until we open the box, the cat isn't truly alive or truly dead, but rather in a probabilistic combination of both states. It's important to understand that this isn't a criticism of quantum mechanics itself, but rather a way to highlight its counterintuitive consequences when applied to macroscopic objects like cats. Schrodinger designed this thought experiment to demonstrate how quantum mechanics, which works beautifully at the atomic level, seems absurd when extrapolated to the everyday world. The key to understanding Schrodinger's cat is recognizing that quantum mechanics describes a world governed by probability, not certainties. It challenges our classical intuition that objects must have definite properties at all times, regardless of whether we are looking at them or not. This doesn't mean that cats can actually be both alive and dead. It is a conceptual tool to explore the fundamental nature of reality. The interpretation of quantum mechanics is still a subject of intense debate among physicists and philosophers. One interpretation, called the Copenhagen interpretation, suggests that wave function collapse is an intrinsic property of the universe, triggered by observation. Another interpretation, the many worlds interpretation, proposes that every quantum measurement causes the universe to split into multiple parallel universes, each representing a different possible outcome. Considering these diverse interpretations, it becomes abundantly clear that Schrodinger's cat isn't simply a bizarre thought experiment. It is a gateway to profound questions about the nature of reality, consciousness, and the role of the observer. Ultimately, Schrödinger's cat serves as a powerful reminder that our everyday intuition, shaped by our experience of a classical world, may not be sufficient to grasp the complexities and strangeness of the quantum realm. The very act of questioning whether the cat is alive or dead forces us to confront the uncomfortable truth that our understanding of reality may be far more fragile and uncertain than we ever imagined. Perhaps the most fascinating aspect of this seemingly absurd scenario is the way it continues to spark debate and inspire new avenues of research into the foundations of physics and the very definition of existence.